Good day everyone, we are Group 3 and today we will be presenting our project entitled Group Report System. So our project is a Java program that computes a student's final weighted average based on the quiz, class standing, and major examination grades together with their corresponding weights. After calculating the weighted average, the program automatically determines the student's grade equivalent, remark whether the student passed or failed, Latin honor classification, and dean's list status. And finally, it displays all of the results in a complete and organized grade report. Throughout this presentation, we will explain every phase of our project, starting from problem understanding and analysis, followed by the algorithm, pseudocode, flowchart, Java implementation, and lastly, our testing and debugging. So without further ado, let's begin with the first phase of our project, which is problem understanding and analysis.
Good day everyone, my name is Nicole Gan. I will be discussing the problem understanding and analysis of our project. So before creating the program, we first identified the problem that we needed to solve. The goal of our project is to develop a Java program that computes a student final weighted average using the quiz, class standing, and major examination grades together with their corresponding weights. The program should not only perform the computations, but it should also evaluate the student's academic performance by determining the grade equivalent, whether the student passed or failed, the corresponding Latin honor classifications, and the dean list status. Finally, all of the results should be presented in complete and organized grade report. After understanding the problem, we identified the three main parts of the program, which are the inputs, process, and outputs. Let's start with the inputs. The program requires the user to enter the student name, the scores of quiz 1, quiz 2, quiz 3, the quiz weight, the class standing grade and weight, and the major examination grade and weight. These are the data needed by the program before it can perform any calculations. That concludes my discussion. Thank you, and I will now turn over the presentations to our next presenter for process and outputs in problem understanding and analysis.
Greetings everyone. My name is Maria Ana Grace de la Cruz and I will be discussing the process and output in problem understanding and analysis. In the process, first, the program accepts all the required inputs from the user. After that, it converts the three quiz scores into percentage because each quiz has a different total number of items. Quiz 1 and Quiz 2 are each out of 35 points, while Quiz 3 is out of 30 points. Once the quiz scores are converted into percentage, the program computes the quiz average, then it calculates the weighted average by multiplying the quiz average, class standing grade, and major examination by their corresponding weights, adding the results together and dividing the total by 100. After computing the weighted average, the program determines the student's grade equivalent based on the grading scale. It also determines whether the student passed or failed, identifies the corresponding Latin honor classification, and checks if the student qualifies for the dean's list. Lastly, the outputs. The program displays a complete grade report containing the student name, the percentage of each quiz, the quiz average, the quiz weight, the class standing grade and weight, the major examination grade and weight, the final weighted average, the grade equivalent, the remark, the Latin honor classification, and the dean's list status. Overall, the problem understanding and analysis helped us identify the requirements of the system, organize the necessary inputs, define the processing steps, and determine the expected outputs before we proceeded to the algorithm, pseudocode, flowchart, and Java implementation. That's all. Thank you for listening.
And for our algorithm is designed to create a complete grade report system for a student. It starts by asking the user to enter the student's name and quiz scores, then convert each quiz score into its percentage equivalent, and compute the quiz average. After that, it accepts the class standing grade, major examination grade, and their corresponding weights to calculate the student's final weighted average. Based on the computed result, the program determines the student's grade equivalent, whether they pass or fail, their Latin honor classification, and if they qualify for the Dean's List. Finally, it displays all the computed information in one complete and organized grade report, before ending the program.
Good day, everyone. Our assigned topics are pseudocode. A pseudocode is a step-by-step description of a program written in simple language before converting it into actual Java code. It helps programmers organize the program's logic and makes the coding process easier. In the first part of the pseudocode, the program starts by asking the user to enter the student name, quiz grades, last standing grades, major exam, and their corresponding weights. After receiving all the inputs, the program calculates the weighted average by multiplying each grade by its weight and adding the weighted scores together. This weighted average will be used as the basis for the next decision in the program.
After calculating the weighted average, the program determines whether the student has passed or failed. It also identifies the student's grade, Latin honor classification, and Dean's List eligibility based on the computed grade. Finally, the program displays the complete grade report, including the student's name, grades, weighted average, grade equivalent, Latin honor, and Dean's List status. After displaying all the results, the program will end. In the end, pseudocode serves as the blueprint of the program because it clearly shows the sequence of steps before writing the actual Java code.
Flowchart is a visual diagram that shows the process or the step-by-step algorithm using shapes that are connected with the arrows. It helps to simplify and easier to analyze how the task works from start to finish. The system begins with the start symbol and followed by the input. In input, the user provides all the data including the student name, quiz score, class standing, and the major exam score, and the percent weight for every academic component. After receiving the input, the program will be calculated the average using the formula.
This process. Here, it performs mathematical calculations to compute the weighted scores for the quiz, class standing, and major exam, culminating in the compute final weighted average and determine equivalent. It also includes logical decision-making steps. It's represented in the diamond shape, evaluating whether the student passed or failed. And it proceeds in assigning to determine Latin honor classification by linking the student's weighted average to the required score. And it's deciding if they are qualified for cum laude, magna cum laude, summa cum laude, or no Latin honor. After, the program will display the student grade including all the inputs and if eligible for Dean's List. Finally, after all calculations and decision logic are complete, the system will show the output by executing display complete grades report to show the final results at the end.
Good day everyone, I'm Ruben Jr. FDL and I will be discussing the Java implementation of our project entitled Grade Report System. So before we go directly to the code, let me first give you a brief overview of what our program does. Basically, our program computes a student's final weighted average using the quiz, class standing, and major examination grades together with their corresponding weights. In our program, the user enters the score for Quiz 1, Quiz 2, and Quiz 3. Each quiz score is first converted into its percentage equivalent. Then the program computes the quiz average. After that, the quiz average, class standing grade, and major examination grades are used to compute the student's final weighted average. Once the computation is completed, the program determines the student's grades equivalent, remark, Latin honor classification, and Dean's List status. And finally, all of the information is displayed in a complete and organized grade report. So let's now go through the program step by step. The very first line of our program is package group 3. This is called the package declaration. Since we created our project inside the group tree package and Eclipse, we declare it here so Java knows where this class belongs. Using packages also helps organize Java files, especially when a project contains multiple classes. Next, we have import java.util.scanner. This line imports the scanner class from the java.util package. We use the scanner class because our project needs to accept inputs from the user through the keyboard. Without importing scanner, Java will not recognize the scanner object, so the program won't be able to receive any user input. After that, we have public class grade report system. This is the declaration of our main class. The class name is grade report system, and you'll notice that each word starts with a capital letter. This follows the Pascal naming convention, which is the standard convention used for naming Java classes. Following this convention makes the code more readable and follows Java coding standards. Inside the class, we have public static void main string args. This is called the main method. This serves as the entry point of the program. Whenever the program is executed, Java starts running the code from this method. That's why every statement that we want the computer to execute is placed inside this block. Next, we create our scanner object. Scanner input is equal to new scanner system.in. Here, we created a scanner object named input. The variable name input follows the common case naming convention, where the first word starts with lowercase letter. This is the standard naming convention for variables in Java. This scanner object allows our program to receive all the data entered by the user, such as the student's name, the 3 quiz score, the quiz weight, the class standard grade and weight, and the major exam grade and weight. So without this scanner object, our program would not be interactive because it would have no way of accepting user input. And after creating the scanner object, the next part of our program is the variable declarations. Variables are used to store the data that will be entered by the user and the values that will be computed by the program. First, we have string student name. So student name is declared with the string data type because a student's name is composed of text or characters. You'll also notice that student name follows the common case naming convention, where the first word starts with a lowercase letter and the second word begins with an uppercase letter. Next, we declare double quiz 1, quiz 2, quiz 3, double quiz average, and double quiz weight. We use the double data type because quiz scores and percentages may contain decimal values. The variables quiz 1, quiz 2, and quiz 3 will store the scores entered by the user for the 3 quizzes. After converting each quiz scores into its percentage equivalent, the program computes their average and stores the results in quiz average. Then, quiz weight stores the percentage weight of the quiz component that will be used later in computing the final weighted average. All of these variables name also follows the common case naming convention, which is the standard naming convention for variables in Java. After that, we have double class standing grade and double class standing weight. Class standing grade stores the student's class standing grade, while class standing weight stores its corresponding percentage weight. Its values are also needed when computing the final weighted average. Next, we declare double major exam grade and double major exam weight. Major exam grade stores the student major examination grade, and major exam weight stores its corresponding percentage weight. These values will also be included in the computation of the student's final weighted average. Next, we have double weighted average. This variable stores the student's final weighted average after combining the quiz average, class standing grade, and major examination grade together with their corresponding weights. Since the result may also contain decimal values, we use the double data type. And lastly, we declare string remark, string grade equivalent, string Latin honor, and string dean's list. So these variables are declared as string because they store a text instead of numbers. Remark stores either passed or failed. Grade equivalent stores values such as 1, 1.25, 1.50, up to 5, or 5. Teen honor stores the student's Latin honor classification, which may be summa cum laude, magna cum laude, or no Latin honor. And finally, Dean's List stores whether the student is qualified or not qualified for the Dean's List. After declaring all the variables, the program displays its title using this statement. System out print line is used to display output on the console. Here, we printed the title grade report system together with separator lines to make the program output more organized and easier for the user to read. And after displaying the title, the program asks the user to enter the student name. System out print displays the prompt enter student name without moving to the next line. Then input the next line, reads the complete line entered by the user and store it in the student name variable. We use next line instead of next because a student's name may contain spaces. For example, Ruben Jr. FDL has spaces, so next line ensures that the entire name is read correctly. After the user enters the student's name, the next part of our program is collecting all the grades that will be used in computing the final weighted average. Here, we're still using system out print to display the message on the screen, while input the text double accept decimal values entered by the user. Since quiz score may have decimal value, we use the double data type. The values entered by the user are stored in the variables quiz1, quiz2, and quiz3, which are written using the camel case naming convention. After getting the raw quiz scores, we converted each course into its percentage equivalent. Here, we're applying arithmetic operators. The division operator or slash divides each quiz score by its highest possible score. For quiz 1 and quiz 2, we divided by 35, while quiz 3 is divided by 30. After that, we use the multiplication operator or asterisk to multiply the result by 100, converting the score into a percentage. This makes all quiz scores follows the same 100-point scale before computing the average. Once all quiz scores are already converted into percentages, we computed the quiz average. So quiz average is equal to quiz 1 plus quiz 2 plus quiz 3 and divided by 3. Again, we're using arithmetic operators. The additional operator or plus signs adds the 3 quizzes percentages together. Then the division operator or slash divides the total by 3 to get the average. The computed value is stored in variable quiz average, which will later be used in computing the student's final weighted average. And next, the program asks for the quiz weight. Again, we're using the input the text double because the weight is also a decimal value. After that, the program asks for the student class standing grade together with its corresponding weight. The values entered by the user are stored in class standing grade and class standing weight. These variables also use the camel case naming convention and will be used later in the computation. And next, we ask for the major examination grade and its weight. Just like the previous inputs, these values are stored using double variables because they represent numerical values. After collecting all the required grades and weights, the program computes the student's final weighted average. This is one of the most important parts of our program because this is where the final grade is calculated. Here, we're using different arithmetic operators. First, the multiplication operator multiplies each grade by its corresponding weight. Then the additional operator adds all of the weighted values together. And finally, the division operator divides the total by 100 because the weights are entered as percentages. This weighted average will become the basis for determining the student's grade equivalent, remark, Latin honor classification, and Dean's List status, which will be discussed in the next part. So after computing the weighted average, the next part of the program is to determine the student's final academic standing. It includes the remark, grade equivalent, Latin honor, and Dean's List status. Remark is equal to weighted average greater than or equal to 75. Here we're using the ternary operator, which is written using the symbol question mark and colon. Condition checks whether the weighted average is greater than or equal to 75. The greater than or equal to operator is a relational operator because it compares two values. If the condition is true, the variable's remark is assigned the value passed. Otherwise, if the condition is false, it is assigned failed. This statement is simply a shorter and cleaner alternative to using an if-else statement. Next, the program determines the student's grade equivalent. Just like the previous statement, this also uses a nested ternary operator. The program compares the weighted average with each grading range using the greater than or equal to rational. Once a condition becomes true, the corresponding grade equivalent is assigned to the variable grade equivalent. For example, if the weighted average is 95, the assigned grade equivalent will be 1.25. If none of the conditions are satisfied, the default value becomes 5 or 5. So after determining the grade equivalent, the program identifies the student's Latin honor classification. Of comparing the weighted average again, this time we compare the value stored in the grade equivalent variable. We're using the dot equals method because grade equivalent is a string. In Java, strings should be compared using dot equals instead of double equal sign, because dot equals compares the actual text values. We also use the logical OR operator. The logical OR operator means that if either one of the condition is true, the entire condition becomes true. So if the grade equivalent is 1.50 or 1.75, the student receives the cum laude classification. Otherwise, the program assigns no Latin honor. And next, the program determines whether the student is qualified for the dean's list. Again, we're using the ternary operator together with the greater than or equal to relational operator. If the student's weighted average is 90 or above, the program assigns qualified. Otherwise, it assigns not qualified. After all the computations are completed, the last part of the program is displaying the complete grade report. These statements print the report header to make the output more organized and readable. Here, we're using the concatenation operator. The plus sign is used to combine text with the value stored in the variable student name, allowing both to appear on the same line. Here, we're using system out printf instead of print line. The two modulo prints the percent symbol, while modulo n creates a new line. This makes the output cleaner and more professional. The same formatting is also used when displaying the quiz average, quiz weight, class standing, major examination, and weighted average. Finally, the program displays the student's grade equivalent, remark, Latin honor, and dean's list status. Each value is retrieved from its corresponding variables and combined with the text using the concatenation operator. And lastly, we call input that close to close the scanner object. This is considered a good programming practice because it releases the resources that were used for user input and properly ends the program. This is considered a good programming practice because it releases the resources that were used for user input and properly ends the program. So that's a complete Java implementation of our grade report system. Throughout the program, we apply the Java concept discussed in class, such as variables, data types, arithmetic operators, relational operators, logical operators, the assignment operator, the concatenation operator, the ternary operator, user input using scanner, and format output using print. And these concepts work together to compute the student's final weighted average and generate a complete and organized grade report. Thank you.
In the testing and debugging, our group provides the sample program output that include discussion. Additionally, the group program was successfully tested using different input values and accurately computed the quiz average, weighted average, grade equivalent, remarks, and dean list qualification based on the given grade criteria. The results match the expected outputs, showing that the calculation and conditions were implemented correctly. During debugging, test cases were used to verify the correctness of the computation and decision-making process. Errors related to the formula, creating condition, and output formatting were identified and corrected. After this improvement, the program ran without syntax or logical errors and consistently produced accurate and reliable results.
For conclusion, this project successfully developed Java-based grade report system that accurately computes the student weighted average and determines their grade equivalent, remark, Latin honor classification, and dean list eligibility. Through this project, the group applied fundamental Java programming concepts, such as variables, operators, and conditional statement, and user input while following the complete software development process from problem analysis to testing. Overall, the project strengthened our problem solving and teamwork skills while demonstrating the practical application for Java and creating reliability academic record system.
I just had to let you know you're